Hello and welcome to this video on differentiation. Today we'll be using our previous knowledge of the product rule, chain rule and quotient rule to find the derivatives of all the trig functions. So let me just start out by listing them. First we have the sine of x, the cosine of x, secant of x, the cosecant of x, tangent of x, and cotangent. So if you know the product rule, the chain rule of differentiation, these will be pretty simple for you. So first of all, a pretty simple formula is that the derivative of sine x is cos of x, and the derivative of the function cos x is equal to minus the sine of x. So these two are really simple and we'll be using them to derive the derivatives of all these others. So this can be remembered very easily because the derivative of sine x is cos x, the derivative of cos x is minus sine x. So I won't be deriving these, maybe I'll do that in a future video, but I will use these two simple facts to derive all the others. So keep in mind that the derivative of sine x is cos of x and the derivative of cos of x is minus sine of x. So let's start off with the tangent of x, or the function tan of x. So here is my function tan of x and I want to find its derivative. So first of all, I'm going to use a pretty simple trig fact that tangent of x is nothing but sine of x divided by cosine of x. Now, because of our previous knowledge of the product rule, we can directly apply it here and rewrite this as, so if you remember, it was low d high minus high and d low, so the derivative of cos x, and this entire thing divided by low square, so in this case cos square of x. Now I just need to do a little simplification. This is cos of x, the derivative of sine of x is also cos x, so here I have the product of these two. So let me write it as cos square x minus sine x, and the derivative of cos x, if you remember, was minus sine of x. So I'll have sine x multiplied by minus sine of x, and this entire thing divided by cos square x. Now this of course is just equal to cos square x, and since I have two negatives I can rewrite it as a positive, and sine square x divided by cos square x. And now fortunately for us, this is a famous trig identity, so cos square of x plus sine square of x is equal to 1. So I can just write this as 1 upon cos square x, and since 1 upon cos x is equal to sec x, this can be written as sec square x. And so finally I have that the derivative of tan of x is equal to sec square x. Now let's move on to the other functions. Okay, so we are going to use a pretty similar approach as we used to find the derivative of tan of x, and we are going to rewrite sec of x as 1 upon cos x, and again we apply the product rule of differentiation. So this we can rewrite as low d high, so that's 1, minus high d low, so 1 times the derivative of cos x upon low square. Now because the derivative of a constant is equal to 0, this first part of the numerator is just 0, so minus, and the derivative of cos x, if you remember, is minus sine of x, so minus sine x divided by cos square of x. Now this I can just write as sine x upon cos square of x, and I can do a little rewriting. So because sine of x upon cos x is tan x, I can rewrite this as tan x upon cos x. And finally, since 1 upon cos x is sec x, I can just write this as tan x into sec x. So now the derivative of secant of x or sec x is tan x multiplied by sec x. Now let's see the third one. Okay, so now we have to find the derivative of cosec of x. So again, we rewrite it and then use the quotient rule. So this is 1 upon cosec x, 1 upon sine x, and using the quotient rule, so I have low d high minus high d low upon low square, so sine square of x in this case. Again, since we have the derivative of 1, this part becomes equal to 0, so I can just rewrite the second term. So minus, and the derivative of sine x is cosine of x upon sine square x. Now I can separate this sine square of x as sine x times sine x, and 1 sine x, using the fact that cos x upon sine x is cot x, I can rewrite this as minus cot x upon sine x, and this is nothing but minus cot x multiplied by 1 upon sine x is cosec x. And so finally, the derivative of cosec x is just cot x, is minus cot x multiplied by cosec of x. Now let's move on to the last one. Okay, so for this one, the derivative of cot x, you can use the same method as before. So you can rewrite it as, since tan x is sin x upon cos x, you can write cot x as cos x upon sin x, and then use the quotient rule of differentiation. But I'm going to proceed using another method just to show you how these formula can also be found. So I'm going to write this as 1 upon tan x, and instead of using the quotient rule, I'm going to further rewrite this as the derivative of tan x raised to minus 1. Now don't get confused between tan x raised to minus 1 and tan inverse of x. They are two totally different functions. This simply means 1 upon tan x, because x raised to the power minus 1 is 1 upon x. And now I'm going to use the chain rule. So I can treat this as x raised to minus 1 first. So I'm using the chain rule here. So minus 1 times tan x raised to minus 2, because I have to subtract 1 from the power. And now using the chain rule, times the derivative of tan of x. This I can rewrite again as 1 upon tan square of x, And as we have seen before, the derivative of tan of x is sec square x. This I can rewrite as cos square x upon sine square x. So because tan of x is sine square x upon cos square x, tan square x. So I can write 1 upon tan square x as cos square x upon sine square x multiplied by sec square x. Now this I can rewrite as 1 upon sine square x. So because since cos x is equal to 1 upon sec x, or rather sec x is equal to 1 upon cos x, these two are inverses of each other, cos square x and sec square x. So I can just cancel them out and write this as 1 upon sine square x. And so that is equal to minus cosec square x, since sine and cosec are inverses of each other. And so finally this is equal to the derivative of cot x. So here you have it, the derivative of cot x is equal to minus cosec square x. And so we have finished finding the derivative of all the trig functions, namely cot, tan, sec, cosec, and of course sine and cosine are pretty simple. So if you know the quotient rule, you can find the derivative of all these functions without having to by heart any of the formulae. Just knowing that the derivative of sine x and cos x and the quotient rule, you can find all these other formulae in a matter of minutes. So there's no need to by heart any of these. So if you found this video useful, don't forget to share it with friends to whom it might be useful as well. Subscribe to the channel to receive future updates about videos, and like the video too. Thank you, and I'll see you in the next video.